Beneath the postcard serenity of the Pacific Northwest, a chain of sleeping giants holds its breath. Snow-bright summits pierce the clouds, their slopes carved by ice and time. They look timeless, unchanging. But the Cascades have shaped this land for millennia, and they can remake it again in a single, violent hour. From Northern California to British Columbia, the Cascade Range shelters some of North America's most dangerous volcanoes. Cities like Seattle and Portland live in their shadow. And while the mountains seem quiet today, geology has a different definition of silence. In 1980, Mount St. Helens proved it, erupting with the force of hundreds of bombs, flattening forests and darkening skies. That was one volcano. There are more than a dozen others, and lately the subtle signals are back. Swarms of tiny quakes, slow ground inflation, faint breaths of gas rising from hidden vents. Are the Cascades stirring? Is the arc waking up? Let us dive beneath the peaks and see what the science, and the past, are whispering. The Cascades exist because the edge of the continent is a factory for magma. Along the western rim of North America, the Juan de Fuca plate slides beneath the North American plate, a relentless process called subduction. As that oceanic slab dives, it heats and releases water into the overlying mantle, lowering the melting point of hot rock. The result is magma. It rises, gathers in reservoirs, and sometimes finds the surface. Over 700 miles of hazards and beauty, Shasta and Lassen in Northern California, Mount Hood and the Three Sisters in Oregon, Mount St. Helens, Mount Rainier, and Mount Baker in Washington, Garibaldi in British Columbia, plus lesser-known cones and domes that dot the backcountry. Most of these peaks are stratovolcanoes, steep, conical, and layered with lava, ash, and fragmented rock. Unlike the broad shields of Hawaii, stratovolcanoes trap gas in sticky, viscous magma. That pressure is a spring wound tight. When it breaks free, eruptions can be explosive and fast, producing pyroclastic flows, ash columns, and lahars that race down valleys. That potential, coupled with dense population corridors and critical infrastructure, makes one of the most consequential volcanic regions on Earth. The Cascades don't just hold potential, they hold history. May 18, 1980, after 2 months of swelling and earthquakes, a massive landslide sheared off Mount St. Helens' north flank, the largest landslide ever recorded. A lateral blast followed, scouring nearly 230 square miles of forest. An ash column rocketed to 80,000 feet, grounding plains and dusting states far to the east. 57 people died. Billions in damage followed. The mountain's profile changed forever. Then, in 2004, St. Helens stirred again. For more than 3 years, it extruded new lava into the crater, building a dome. Quieter than 1980, but a clear message. This system is alive. St. Helens is not alone. Mount Rainier, the crown of Washington, has erupted repeatedly over the last 10,000 years and is infamous for its lahars, volcanic mudflows that can thunder down river valleys with little warning. Mount Hood in Oregon erupted in the late 1700s and remains capable of new activity with a short lead time. Mount Shasta has erupted several times in the last few thousand years. The cataclysmic collapse of Mount Mazama, about 7,700 years ago, formed Crater Lake after burying vast areas in ash. History's message is simple. These volcanoes sleep between eruptions, but they do not die. Over the past year, scientists have been quietly tracking a series of faint but significant warnings from the Cascade volcanoes. Beneath Mount Adams, a small swarm of earthquakes, more than a dozen, each below magnitude 2, rippled through the crust, too weak to be felt but strong enough to raise eyebrows at monitoring stations. Mount St. Helens, long known for its volatility, continues to emit low-level seismic noise, a restless echo that has persisted since its dome-building phase ended in 2008. Even Mount Rainier and Mount Hood, typically calm, have registered occasional microquakes, subtle pulses consistent with their usual background activity, yet reminding scientists that these systems are never truly dormant. Meanwhile, GPS and satellite radar have detected faint undulations across the ground, minute rises and falls that may signal the slow movement of fluids or magma deep below. At times, instruments have picked up fleeting traces of sulfur dioxide and carbon dioxide escaping through ancient fractures, as if the mountains themselves were exhaling. None of these signs alone point to an imminent eruption, but together they suggest a landscape quietly shifting, rebalancing, preparing. Volcanoes, after all, can transition from routine calm to restless awakening in the blink of a geological eye. For the experts watching, the mission now is patience and precision. Monitor the data, trace the patterns, and listen closely for the moment when the Earth's rhythm begins to change. The Cascades host many hazards, but a few loom largest. Rainier's ice and snowcap can turn modest eruptions, or even sector collapses without eruption, into deadly lahars. Those mud flows can reach populated river valleys in under an hour. More than 80,000 people live in mapped lahar zones downstream. This is why Rainier is often ranked America's highest volcanic risk, not necessarily for eruption frequency, but for consequence. Hood rises within easy view of Portland. Shasta towers over vital transport corridors in Northern California. Even small events could close. Highways, contaminate water supplies, and ash coat communities. Larger eruptions could reshape entire seasons, commerce, agriculture, and flight paths included. Mount St. Helens, the quick changer. It has a known capacity to escalate from swarms to surface activity fast. A future explosive phase could unleash pyroclastic surges, widespread ashfall, and lahars in river systems already altered by the 1980 eruption. Others not to ignore. Glacier Peak, Baker, and the Three Sisters have histories that demand attention. Glacier Peak's prehistoric eruptions spread substantial ash. South Sister saw ground uplift between 1997 and 2001 that drew intense study. Baker exhales heat and gas through its fumaroles. It has produced lahars in the historic period. Primary hazards: ashfall, lahars, pyroclastic flows, landslides, and volcanic gases. Secondary impacts: power and water outages, air traffic disruption, transportation shutdowns, crop impacts, losses that can climb into the tens of billions. How we watch the giants. The USGS Cascades Volcano Observatory in Vancouver, Washington, serves as the nerve center for monitoring the entire volcanic arc of the Pacific Northwest. Working in close coordination with the Pacific Northwest Seismic Network and multiple local, state, and federal agencies, the observatory maintains a constant watch over the region's restless peaks. Every tremor, from faint microquakes to rhythmic harmonic vibrations, is logged and analyzed. Arrays of GPS receivers and INSAR satellites measure the slightest shifts in the land, sometimes just a few millimeters of uplift or sinking, revealing the slow pulse of magma and pressure beneath the surface. Gas sensors track changes in sulfur dioxide, carbon dioxide, and hydrogen sulfide levels, each fluctuation offering clues about degassing magma or the movement of molten rock through hidden conduits. Thermal cameras and orbiting satellites scan for subtle temperature anomalies, while hydrologists study the chemistry and heat of local springs and streams for signs of volcanic influence. Together, these layers of data form a living portrait of the Cascade Range, one that allows scientists to sense the mountain's mood long before it speaks. Public readiness has improved. Hazard maps exist, schools and towns conduct drills, lahar sirens are tested, evacuation routes are posted in several valleys. New tools, machine learning on seismic waveforms, cloud-based data fusion, near continuous satellite. Revisiting the need to tighten the loop between signal and alert. But gaps remain. Rugged terrain and wilderness make coverage uneven. Some stations are old or remote. budgets stretch thin, and forecasting remains probabilistic, volcanoes do not run on schedules. The difference between resilience and disaster is often speed, coordination, and practice. These volcanoes do not need a dramatic trigger to awaken. Sometimes the smallest shifts beneath their slopes are enough to tip the balance. Scientists watch for patterns. Earthquake swarms that migrate upward through the crust. The subtle transition from scattered quakes to rhythmic, long-period tremors that hint at rising magma or trapped gas, or sudden localized ground deformation beneath a summit or flank. Sharp increases in sulfur dioxide emissions or changes in the ratio. A shift in the balance between carbon dioxide and sulfur dioxide can signal fresh magma rising from depth. Even the appearance of new fumaroles, patches of rapid snowmelt, or persistent thermal hotspots can suggest that heat is moving closer to the surface. No single clue tells the whole story, but when these signals begin to align, quakes, uplift, gas emissions, the warning picture grows sharper, and time becomes a precious commodity. The Cascades, by definition, are alive. They are not extinct, and they won't be in our lifetimes. Their stillness today is deceptive. These systems spend centuries between eruptions, only to awaken without mercy when the cycle turns. The sequence never truly changes. Unrest, eruption, recovery, quiet, repeat. Yet two growing forces could make the next chapter more complex than any before. The first is climate change. As glaciers retreat, the weight pressing down on volcanic slopes lessens, subtly reshaping stress fields and weakening already unstable terrain. This can trigger landslides or lahars even without a traditional eruption, turning ice melt and gravity into agents of destruction. The second force is human expansion. Towns, highways, and power lines now sprawl into zones once considered remote wilderness. A century ago, an eruption here might have scarred forests. Today, it could cripple entire communities. We possess the science to understand these volcanoes better than any generation before us. What remains is resolve. The commitment to fund the instruments, maintain the networks, run the drills, and teach the escape routes. Because knowledge alone doesn't save lives. Action does. So, are the Cascades waking up? Right now, most signals fit the background pulse of an active arc. But the frequency of small swarms, scattered deformation, and intermittent degassing is a reminder, not a reassurance. The question isn't if the Cascades will erupt again, it's which, how, and when.